Hello everyone and welcome to my channel. I'm Dr. Anand Kumar Gupta and we will start our second video in this RIP video series. In this video lecture, we'll be seeing how to configure routing information protocol on Cisco Packet Tracer. Cisco Packet Tracer is a network simulation tool provided by Cisco Incorporation. So I have already installed Cisco Packet Tracer on my system, as you can see. If you haven't installed Cisco Packet Tracer, you should go to netacad.com, create one account, download Cisco Packet Tracer from there, and install it on your system. So meanwhile, you can pause the video, you can download the Cisco Packet Tracer, install. Installation process is very straightforward. And after that, you can see you have the similar kind of shortcut icon on your system. Once you double click, it will start the Cisco Packet Tracer window like seen in this one. In this video series, I'll be discussing how to configure RIP using graphical interface and also command line interface. So for now, let's create our network topology. I'm going to use router 2621XM and I'll use one more router. These two routers would be connecting to different network. I'm going to use switch. So you can see on the devices section, I have selected the switch. I'm going to select 2960 switch. So we need two switches here. Then I'll be using 4 PCs. And we'll be connecting them using the connection. So I'm using a straight through cable. I'll be connecting to fast Ethernet 0x23, fast Ethernet 0x24 to PC fast Ethernet 0 network card. Similarly, I'll connect the other end. For the uplink, I'll be using gigabit Ethernet 0x1 and I will connect it to routers fast Ethernet 0x0. Vice versa on the other network. By default, the router has only the modules which allow you to connect a local area network. If you want to connect your network through the wireless wide area network or WAN, you need WAN interface. So on Cisco switch or Cisco router, we can see there is a WAN ports slot available, but the ports are not available. We're supposed to buy and connect the serials ports or slots. So normally Cisco says you have to turn off the device, then you can connect the modules or disconnect the module. On the left side of the screen under the physical tab, you can see the modules slots which are empty for now, and on the left you can see the list of modules available. I'm going to use WIC1T, that will provide me one serial port. You can drag this one and release to the empty slot. Once you have released to the empty slot, you can see the slot is vacant now. The slot is occupied now. You can turn on the router. Same process we are going to do on the next router. We'll be turning off, then drag the WIC1T module in the slot and turn on. The moment your devices has been modules connected, we'll be using a serial DC cable to connect. The Port should be serial 0 by 0 on router 0 and serial 0 by 0 on router 1. Once it is done, now it's time to configure. So I'll be quickly assigning the series of IP. I'm going to use 100.0.0 slash 8 network for WAN connectivity. I'll be using 10.0.0 slash 8 network for local area network connection. I'll also be using 172.16.0.0 slash 16 for the other network. So it's a straightforward. We have to assign the first IP to the first Ethernet 0 by 0 that will serve as a gateway. Then the remaining IPs I will be assigning to the PCs and the gateway of this IP. So let's go through and quickly assign the IPs to the system. Click on PC, go to desktop, IP configuration, 10.0.0.2. I'll be using 10.0.0.1 IP as the gateway IP on the router. We'll follow the same step. So I'm just going to quickly configure it, and on the next network we'll be configuring 172.16.0.2. Subnet mask would be 255.255.0.0 and the gateway would be 172.16.0.1. So as you can see, I have configured, so the devices having IPs now. The next step is to configure the router. So we'll click on the router. I'm configuring graphically for now so that you can understand. Then later on, using the same diagram, I'll be showing you how to configure using the command line interface. So I'll go to configure. We will select the router name. Display name is router 0. I'll give a name called branch 1. The host name, I'll be also changing it to branch 1. Then we'll go to fast Ethernet 0 by 0 because this is the interface connected. I'll check the box to put the port on and the IP address 10.0.0.1 and subnet mask. Once it is done, we are good to go with the next interface. Fast Ethernet 0 by 1 is not in use for now, so nothing to do on that. We will select the serial 0 by 0, put the interface on. We will select the clock rate. Clock rate is the bit rate on which the data from one router to another router will flow. So we can select one available clock rate. In real situation, this clock rate is actually the bandwidth provided by the ISP. So you have to specify that bandwidth there. For now, let's configure the interface IP, which is 100.0.0.1. I think I have typed something incorrect. So 100.0.0.1 and the subnet mask is 255.0.0.0. You can also see in the command prompt, these are the equivalent commands which can be used. So no shutdown when I check the box on, clock rate when I choose the clock rate speed here, when I specified IP address, this is the IP address which we have specified. So to assign IP using the command line mode, you have to execute this command. Later on, you will see that one. For now, our configuration is done. So we can close this. We'll go to the next router and we will follow the same process here. So you can also see if I If I turn on the interface, what happens? Like, you focus on this line. I have selected fast Ethernet 0x0 on. You can see the port is on, and there in the bottom you can see there is a command we have. We can see equivalent command, that is no shutdown. The IP address 172.16.0.1 and the subnet mask. You can also see the IP address command, IP address 172.16.0.0 255.255.0. First Ethernet 0x1 is not in use. We'll be using serial interface. Turn on. On this side, we should not specify the clock rate. It will automatically detect the clock rate. We can just assign the IP address, and that's it. So we got the interfaces up. Now, the last process is to uh, configure the routing information. So to configure routing, we will go to the router again, and there we have routing information protocol configuration, RIP. We have to specify what are the networks connected directly with this router. So you can see the network 100.0.0.0 is connected and 10.0.0.0 is directly connected with this network. What we have to say, we have to type 100.0.0.0 and add, then network 10.0.0.0 and add. So you can see if we are in the global configuration mode, we can type router RIP command. This command will take us to the routing protocol configuration mode, and you can see the prompt has been changed, network, and followed by the network address of directly connected network will mark the entry in the routing table. This is done. We'll go to the next router. I think I did not mention the display name, so I will quickly change it to branch 2. Router name should be branch 2, and we'll go to RIP. For this network, there is 172.16.0.0 network and 100.0.0.0 network is directly connected. So we have to say 100.0.0.0 add and 172.16.0.0 and add, and compare the command. So these three commands will help you to configure the routing information protocol. Once it is done, it's time for testing. So we know the IP address of this computer 10.0.0.2. This one is 10.0.0.3. This computer has IP 172.16.0.2, and this one has 172.16.0.3. So we know the neighbor PC where we want to ping is having the IP either 172.16.0.2 or 0.3. We will go to the computer. We'll use the command prompt, and we are going to check what IP is assigned on this one. So we'll type the command ipconfig. Ipconfig will show you the IP address 10.0.0.2, subnet mask, and the default gateway. Now let's ping on this computer to check whether the connectivity is happening or not. We'll type ping command followed by the IP address of the device which we want to test. And once it is done, press enter. The first packet is expected to be dropped. As you can see, request timeout is done, but following packets are reaching to the device. It means our route has been established, and you can see the connectivity is up. The same thing you can also do using the packet simulation. You can use PDU. You can click on the PC from where you want to originate the PDU, and you can click on the destination PC, and in the simulation area you can see the PC 0 has pinged to PC 3 and the connectivity is up and running. So that's it for this video.